Now, in this video, we are going to take up one more problem on shafts. The problem reads as, a solid shaft rotating at 1000 RPM transmits 50 kilowatt. The maximum torque is 20% more than the mean torque. The material of the shaft has the allowable shear stress of 50 MPa and modulus of rigidity is 80 GPa. Angle of twist in the shaft should not exceed 1 degree in 1 meter length. Determine the diameter of the shaft. So it has been asked in December 2008 and January 2009. So here, the solid shaft rotating at 1000 RPM, so N is 1000 RPM, small n, and capital N will be equal to 50 kilowatt. The maximum torque is 1.2 times the T mean. 1.2 times the T mean because 20% more than the mean torque. The material of the shaft has the allowable shear stress. Tau is 50 MPa, which is equal to 50 Newton per mm square. And modulus of rigidity G, which is 80 GPa, equal to 80 into 10 to the power of 3 Newton per mm square. Angle of twist, theta is 1 degree, so naturally it should be 1 into pi by 180. And length is 1 meter, which will be equal to 1000 mm. So I need to determine the diameter of the shaft. Since he has given power, the power transmitted by the shaft, capital N, will be equal to 2 pi N into T, capital T, by T mean by 60,000. So substitute the value of capital N as 50 and small n as 1000. So 50 will be equal to 2 pi into 50 into 2 pi into 1000 into T mean divided by 60,000. So therefore, on calculation, we will going to get the mean torque. T mean will be equal to 477.465 Newton meter. So convert that into mm. That will be equal to maximum torque will be 1.2 times 477.465, which will be equal to 572.958 Newton meter, which will be equal to 572.958 into 10 to the power of 3 Newton mm. Once you get the torque, now based on the torsional strength criterion, we want to find out what is the diameter of the shaft. So T by Jp will be equal to tau by R. So T will be equal to Jp by R into tau, which will be equal to Zp into tau, where Zp has pi dq by 16 into tau. So we know the torque, which is given to be 572.958 into 10 to the power of 3 Newton mm, which will be equal to pi by 16 into d cube into tau is 50. On simplification, we will going to get the diameter of the shaft as 38.8 mm. Now we will going to take up based on the rigidity criterion or the torsional rigidity criterion. Again, T by Jp will be equal to G into theta by L. So we know the torque value, so that is 572.958 into 10 to the power of 3 divided by Jp, which is pi by 32 into d to the power of 4, or pi d to the power of 4 by 32 will be equal to G is 80 into 10 to the power of 3 into 1 into pi by 180, because it is in degrees, you have to convert into radians, divided by the length of the shaft, which is 1000 mm. So therefore, on simplification, the diameter of the shaft, what you will going to get is 45.2. So when you are comparing between these two, that is the diameter of the shaft from the torsional strength criterion and also the diameter of the shaft from the torsional rigidity criterion, if you are comparing these two. So based on the torsional rigidity criterion has got the higher value of diameter of 45.2. So you adopt the permissible diameter of the solid shaft is higher among the two values. So you adopt the diameter. Therefore, the permissible diameter of the solid shaft based on the torsional rigidity criterion will be applicable for diameter is 45.2 mm. So this is how you will be able to solve this particular problem. Thank you.